Good day, everyone. I'm Gan Lee from Empathic Computing Lab at the University of South Australia. The title of the paper I'm going to present is Enhancing First-Person View Task Instruction Videos with Augmented Reality Cues. My co-authors are Dr. Seungjun, Professor William Hoff, and Professor Mark Billinghurst. Time to time, we feel like we need to learn how to do things, such as learning how to cook a new type of dish, or maybe it's when we are trying to learn how to draw things, or maybe it's the next DIY project. Where do we find such information? Turns out, about 70% of millennials watch YouTube video to learn how to do something new. In fact, in North America alone, over 100 millions of hours of to-do videos are being watched, and how-to videos on YouTube grew 70% year to year in 2015. Videos are very useful to learn how to do new things. However, they are not perfect, especially since there are 2D information shown on the screen. They are limited in terms of conveying the idea of spatial relationship or spatial configuration. They also suffer from separation between the task guidance information and the task space, which is the physical world. To overcome this problem, we are trying to look into how we can combine instructional videos with augmented reality technology. There have been active investigations around how AR could be useful for guiding tasks in the real world. In fact, many researchers have looked into different types of visual cues to use them to guide tasks in the real world. And of course, among the many different visual cues, there were also previous studies looking into how video recordings could be useful in an AR guide system. There are also, in fact, commercial solutions becoming available, such as Vuforia Expert Capture. Compared to this prior work, our work focuses on a simple and low overhead approach to communicate task instructions for collaboration. Especially, we focus on a system supporting a co-located asynchronous collaboration in a room-scale environment. AR Tips is a wearable AR system that allows you to record first-person view video along with other spatial information and share with someone who needs that information in the same co-located space. The instructor will record his or her first-person view video while he is performing the task in the physical task space. And as he is recording the video, the system will not only record the first-person view video, but also record spatial information such as the instructor's head position and orientation and where the focus of the instructor is, and also augmented reality cues. It also records those information as well. Once the task guidance information is recorded, it can be shared over onto the cloud server and then shared to a viewer who will be located in the same physical task space, but at a different time, watching the first-person view video along with other spatial cues. We try to make the AR Tips applications as simple as possible to be a lightweight tool for co-located asynchronous collaboration. The visual cues that we designed and implemented in AR Tips include a video inset and view focus cues such as the white arrow and the white circle that indicates where the instructor's focus is. The system also supports visual cues for highlighting objects such as the red circle and a glow around it. The system is implemented based on a Microsoft HoloLens and using Unity 3D game engine. Here's a short video clip of how the system works. First of all, the instructor will record the instructional video using our AR Tips. Come to this shelf, pick up this card and place it there. Next, pick up this white adapter and place it there. After the video is recorded, it is shared to another user who is trying to learn how to do things. Come to this shelf, pick up this card and place it there. Next, pick up this white adapter and place it there. Next, come to this wall. Count the number of yellow sticky notes on this wall and write that number on this cell on the whiteboard. We tried our AR tip systems in several use cases, such as setting up a seminar room, or operating a copy machine, or as a tour guide into our lab spaces. In order to formally assess the proposed concept, we conducted a user study. The main research question of the user study was, how do AR cues affect user performance and experience while following instructions on a first-person view video? The study was designed as a within-subject experiment with two conditions. The first condition was video only as the baseline condition, and the second condition was video with AR spatial cues. The task was preparing an office room for a VR demonstration following the task instructions provided on the AR tip system. This picture shows the user study environment. The user study followed the following procedure. First, the participants were welcomed and introduced to the study. After them signing the consent form, they filled in the demographic questionnaire. Next, the study was split into two sessions. The first session was focusing on the viewing task, while the second session was on the ordering task. In the viewing task, participants had to perform following the instructions shown on the AR tip system under two conditions and answer to the questionnaires as their subjective feedback. We also collected objective measurements such as task completion time and number of errors. The second session on the ordering task was more exploratory style user study, and they were given a task to record a first-person video. 18 participants were recruited from our local university. 3 of them were female, and their age ranged from 22 to 40. Most of the participants were familiar with AR interfaces, which made the minimal impact from the novelty bias. The results showed that the condition with the AR spatial cues significantly reduced the task completion time and also the error made by the participants. Based on the user activities collected through a system log file, the results also show that the angular difference between the focus point of the user and the video was significantly reduced in the condition with the spatial cue. The results also showed that the participants had to rewind the video less number of times in the condition where the augmented reality spatial cues were available. In terms of subjective feedback, we collected task difficulty and mental effort. The results showed that the condition with the spatial cues had made the task significantly easier and also significantly reduced the mental effort. The results from the system usability scale indicated that the condition with the AR spatial cue had significantly higher usability compared to the condition without the spatial cue. The results from the custom rating items indicated that the participants enjoyed the experience, was able to clearly understand the task instructions, and was able to clearly understand where to look at, and was able to focus on the task activities significantly more in the condition with the spatial cues. All except one participant preferred the condition with the visual cues. Only one participant had no preference between the two conditions. When participants were asked the reason why they preferred the condition with the AR spatial cues, they answered they were able to focus on the real-world task more compared to the other condition. The participant appeared to be paying attention to the spatial cues rather than the video instead itself. 2/3 of the participants indicated they preferred the view-focused cues amongst the other visual cues. In the second session, the participants were asked to create an instructional video using AR tips. The results indicated the AR tips were very useful and easy to use to create instructional videos. We also asked participants what are the suggested improvements for the AR tip systems. There were 3 major themes identified. First, it was to improve playback controls, such as allowing the user to change the playback speed or allowing them to jump to a specific part of the instruction video. Improving visual elements was another common theme in the user's feedback. Participants also suggested to improve the system by supporting hierarchical structures in the instructional videos. Overall, the user study results supported that AR cues can improve users' task performance and user experience. The AR cues were found especially effective on guiding users' focus and attention in the real-world space. The user study also identified rooms for improvement in the playback control, supported visual cues, and content structure. We also note that we need further investigation with longer-term real-world tasks in follow-up user studies and with wider pool of participants. Thank you very much. Please refer to more details to our paper. Thank you.